Okay, so this is the introduction to decimals, and I'm hoping that a lot of this you will have done in Year 6, okay? Or maybe even in Year 5, I'm not sure, but hopefully you've done it in the junior school at some point. So we're just going to run through a bunch of different examples that highlight a bunch of different things about decimals. And this is everything you basically need to know at this point. So the first thing is, well, what does this notation actually mean? So the idea is that the first position after the decimal point is tenths, 1/10. The next position is 1/100ths, 1/100th. The next position is 1/1000th. Okay, these are ones, these are tens, and these are 100ths. So the idea is that each position that you go down, you divide by 10. You could also say every position that we go up, we multiply by 10. That would be the same thing, okay? But that's the most important thing to know, that every time you go down a step, you divide by 10. So I can actually answer this question now, which is it's 7 lots of 100, 3 lots of 10, 4 lots of 1, 6 lots of 1/10, 2 lots of 100th, and 5 1,000ths, 5,000ths, okay? You could write this little bit as 6 over 10 if you like. You could write this little bit as 2 over 100, and you could write this little bit as 5 over 100,000, sorry. Would be the same. Okay, so we could do exactly the same thing here. Hey girls, you might need to pause if I go too fast, just to write things down. So again, we've got hundreds, tens, units, and tenths, hundredths, and thousandths. Whoops. There we go. Okay. So that really is the most important thing for you to know right now. So let's go through here and do some true-false questions. So, does 0.3, and what I'm going to do, girls, is I'm just going to do some of these, and the ones that I do I'll circle, and everything else is for you to do afterwards, okay? So 0.3 means 3 of 10 equal parts. No, that doesn't make any sense whatsoever, okay? Is 0.4 the same as 0.40? Well, yes it is, because this, all it's doing is it's just saying 0 lots of 100ths. And if you have 0 100ths, what do you have? You've got nothing. So they're exactly the same. Okay? Let's have a look at this one. What about this one? Is 0.7 the same as 0.07? Well, no. This is 7/10. This is not 7/10. This is 7 1,000ths. So they are different. What about this one? The value of 7 in 6.174 is 7 100ths. Well, yes, because this is 1/10. The next one after 1/10 is 1 100th, and there's 7 of them, 7 100ths. And probably the other one more that I want to do with you is this one. 0.14 has 2 decimal places. The answer to that question is yes. When we talk about decimal places, we talk about number of digits after the dot. Okay? How many digits after the dot? 1, 2. 2 decimal places. So here's a number with 5 decimal places. 0.302222. Okay? So that one has 5 decimal places, which we call DP, decimal places. Because my class knows this, mathematicians, we're all lazy. DP is easy to write than decimal places. Write each sum as a decimal. So I'm going to do A, I'm going to do C, I'm going to do E. So A. So the first thing to check is the first one 1/10? Yes, it is. So that goes in the first decimal place. So there's a 6 there. And then just look, is the next one 1/10? Well, 10 times 10 is 100. We've got one extra 0. Yes, it is. There's a 4 there. Finished. C. Is the first one 1/10? Yes, it is. So it's 0.2. Remember, this one here would be units. There's no units there. There's 2/10 first. And then I just look from here to here. Do I add 1 0? Yes. From here to here, do I add 1 0? Yes. So there's no skipped places. Is the first one 1/10? Yes, it is. From here to here, do I add 1 0? No. Okay. So this would actually be 3/10 plus 0 1/100ths. So they're trying to trick us, but they didn't. We're too quick for them. So there's a 0 there. Okay. The zeros are really important, right? Just like in normal numbers, right? What would you rather have? $41 or $4,001? Well, aren't they the same? This just has zeros. The answer, of course, is no. We want $4,001. The zeros change the place value. Okay, that's what's important about decimals, is place value. Expanded form. I'm just going to do B because I've done a couple of these already. So that's 3 units, 4/10, 800ths, 3,000ths. I'm going to give you a D to do later as well, which is 10.2015. I'll write the answer later if I remember. I might not. Are these pairs the same or different? So I was just reminded to pause if I go too fast and write down and stop and think, because the video is only going to go for about 15 minutes. The lesson goes for 1 hour. 0.1 and 0.100, are they the same? Yes, they are. Because this one's 1/10 plus 0 100ths, which is nothing. This one is 1/10 plus 0 100ths plus 0 1,000ths, which is also nothing. They are the same. Are these two the same? Well, the 1 is in the second decimal place, which is 1 over 100. The 1 is in the third decimal place, which is 1 over 1,000. They are not the same. What about these two? Again, the 0 changes things. This one is 1 1,000th. This one is 1 100th. They are not the same. Okay, place value matters. Position matters. So ascending order. Ascending means going up. So let's see. What do? I'll do A, I'll do C, and I'll do H. So A, which one's the smallest? 3/10, 8/10, 6/10. So they're all the same decimal position and number of decimals. So I can just look at the numbers and arrange them in order. So 0.3 is smaller than 0.6 is smaller than 0.8. Can I do the same for the next one? No, I can't, because this one has 1 decimal place. This one has no decimal place and it's a unit, and this one has 2 decimal places. Now the way people get tricked is they think 2 decimal places is bigger because there's more numbers. So it's actually wrong. Just look at the first decimal place, right? So the 1 is obviously the biggest because it's a unit. These are both smaller than units. And now just look at the first decimal place, which is the tenths column. This one has 5/10, this one has 8/10. So the 5/10 is smaller because the next number is only hundredths, and there's no way to get up to the tenths from there. Okay, this is a very tricky one. 0.1, 0.09, 0.8. So this one is the smallest because the first decimal place is a 0. The other ones both have non-zero first decimal places. It's the smallest, it's just 9 1,000ths. Now you look at the decimal places. Right, this is 1/10, this is 8/10. Clearly I would rather have 8/10 of a cake than 1/10 of a cake. How many decimal places? This one, this one, this one. A, there are 2 decimal places, 1, 2 numbers after the decimal point. 1 decimal place, 1 number after the decimal point. How many are there here? There's 1 non-zero number, but the zeros count. There are 2 numbers after the decimal point. Right as a decimal. Okay, so I'm going to do this one, and 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 this one. Okay, so the way to do this is to count how many zeros there are. That's how many decimal points you're creating. So there's 2 decimal points, and there's 2 digits on the top. So they just go smack bang down. So this one has 1, 2, 3 decimal points. 1, 2, 3. And then I need to put the number 7 in. So the 7 goes there because it's 7 1,000ths. And I need to put it in the third decimal point. So I do that by putting zeros in front of it. Okay. So for the next one, there are 3 zeros. So there are 3 decimal points. But I've got 3 digits on the top, 125. So I'm good. 2 decimal points, 2 numbers on top, but there's 2 holes as well. So I put the holes in front of the decimal point. 2 decimal points, but there's also 10 holes in front, so I'll put them down first. 2 decimal points, only 1 number on top, so it's 10.09. And then lastly, L, 8 in front, 3 decimal points, so 2 zeros are needed, and then a 5. Do these ones. So 1 decimal point, so the number on the bottom must have 1 0, a 10, 7 on top. 2 decimal points, the number on the bottom must have 2 zeros, 100, 7 7. 3 decimal points, so the number on the bottom must have 3 zeros, just like that. I'm going to do a special one, M. So there's 1, 2, 3 decimal points. Oops, spoiler alert. 3 zeros. And then I just put the number on the top, which is 1. 0, 0, 1 is just 1. Okay, we already did this. I'm just going to do that one. That one. So, the way to do these ones are slightly different. I just write down 7406. And then I say 1, 2, 3, 0, so there must be 1, 2, 3 decimal points. There goes the dot. 4, 5, 0, 4. 2 zeros, 2 decimal points, 1, 2. There goes the dot. Can do another special one. So, I write down the number 23. There are 1, 2, 3, 4 zeros. So we must need 1, 2, 3, 4 numbers, and then the decimal point goes there. So I have to add some zeros in. So C, you don't need these zeros, do you? Just 3/10. E, you don't need this 0 either. It's just 7/10. G, this 0 matters because it tells me that there's 2 decimal places, so it's 100th, not 1000. So K, you don't need that 0, it's at the end, but you do need that one. So it's 3 over 100. Okay, back to some more place value questions. Do my ASIG, maybe? Sure, why not? A, so the 5 is here, and that's 500. So the value is 5 lots of 100 or 500. Okay, this time the 5 is in the third decimal point, so 5 and 3 zeros, which is exactly the same as this one, actually. Look at where the 5 is, it's in the same spot. So it's also 5 over 1000. This one is in the 1, 2, 3, 4th decimal spot, so I need 1, 2, 3, 4 zeros. And we're on the last one. 14 plus 6 100ths. Is that the same as 14.6? No. 100 would mean second decimal point, not first. So it would need to be 14.06 to be correct. Is 0.97 bigger than 1? No. This is 1 unit. This is less than 1 unit. Okay? And notice, I really need to highlight this. This is 0.3. Oops. 3. 0.33. Whoa, 33. The reason we make you not do this is because it's all about place value, right? And what you're saying is it's 0 point, a 3, and then another 3, and each of those 3's have place value. If you say 33, you might get confused and put it like this. Okay, that's why we make you do it like that. Okay, I hope that wasn't too fast or confusing in any way, but you should have a conference now where you can ask your teacher for help. Thanks, girls.